My name is Taira Augusto, and I'll be a moderator for today's Energized SAGA episode. This is our third episode. It's going to be on drilling operation with the brilliant mechanical engineer Julia Hedderson. She's a project manager at Technip FMC in Houston. She has 11 years of experience in the oil and gas industry. She has worked as an offshore installation engineer in field management and also account management, and she'll be giving us her insight and knowledge in drilling operation. She also will share her experience. If you have any questions, please comment down below on the question box and they'll be answered at the end of the session. Thank you so much, Julia, for joining us and becoming our speaker. I hope everyone enjoyed the session, and thank you again.
You are very welcome. I'm honored to be here today to share with you some information about how to drill a well. As was stated, I've been in the industry for just over 11 years now. I come from a small community in Eastern Canada, around St. John's, Newfoundland, and I studied at Memorial University. I came to Houston and embarked on my career straight out of university, and I've never really looked back. I've been afforded many opportunities here, and I look forward to sharing with you my presentation, but also I really look forward to some questions at the end. I am here for you. I am here to answer your questions. Hopefully provide you with some ideas, some information on ways that you can get involved in the oil and gas industry. So please enjoy and let me know at the end if you have any questions at all. So with that, I will share my screen for you all and we'll go through my presentation. Okay, so this is episode 3. I was able to see some of the other presentations that you saw, and I think this will fit in nicely to give a full picture of everything that you've learned thus far. As far as drilling operations go, my plan for today is to go through a few items, as you can see on the agenda. So I'm going to give a brief overview of the oil and gas industry. I am sure many of you already know a lot of details about the oil and gas industry, but I thought it would be good to ground us and get us started that way. Then I plan on getting in depth on the exploration and production part of the oil and gas process. And then the real meat of the presentation is the drilling of a subsea well. So with that, I'll go ahead and get started. So the oil and gas industry didn't just start overnight. It began about 200 million years ago when anaerobic decomposition of organic matter settled on the Earth's surface and began to compress, and with heat, the movement of the earth really created these deposits of rich organic sludge at the bottom of the ocean. So oil and gas were formed by this, and then over time, the organic material mixed with sediments formed the shale, or the source rock, and that is the source of the hydrocarbon. The oil will flow from the source rock and accumulate in thicker, more porous limestone or sandstone, and that's our reservoir rock. That is what ultimately is where the hydrocarbons reside and where we want to extract the hydrocarbons from. So if it's below the sea level and underneath the mud line, the question is really, how do we get that hydrocarbon from the reservoir rock? So our oil and gas industry has many ways in which we get the hydrocarbons from point A, being trapped in a reservoir, to point B, which is being able to be used in our daily lives. So there's a lot of work that goes into getting that hydrocarbon to where we can use it. And there's specific sectors of the industry in which are used to focus on that. So upstream is where I work, and that encompasses the subsea development. And the focus that we have, and I work at a service company, Technip FMC. Our focus is to provide services and equipment to enable operators to be able to get the hydrocarbons from the reservoir safely, effectively, to ensure that we play our part in enabling the recovery of hydrocarbon. So that's the focus that I'll really talk about today, is upstream, because that's where exploration and production and drilling fall under. But then further on past upstream to the midstream is where you would transport that hydrocarbon. So eventually, once the hydrocarbon is extracted and brought to a production facility, which I'll get into the details on that as we go through. But there has to be a way to get that hydrocarbon in an unrefined process to eventually be able to be used. So you need to be able to transport that in pipelines. Those can be subsea pipelines, and then oftentimes they go back to the beach. So it would leave, the subsea field and be carried to back to, land. And then it would go into a refinery and be further processed to usable oil and gas that we can use in our daily lives. So examples of ways in which we can use oil and gas are in our vehicles, clothing, fuels, accessories, household items, beauty, the list goes on and on. And we, every part of the industry, the three different sectors, plays a huge role in getting oil and gas to be in a usable form. So it creates a lot of jobs, and it's a very interesting field to be in. And I think for me, a part of, appreciating what you do is understanding how it is being able to be used at the end, once it's fully refined for use for people. So it's good to see the whole picture and kind of understand that it all comes from that anaerobic material that originally, formed under layers and layers of rock. And it now, after a lot of process, a lot of people, a lot of engineers, we are able to get oil and gas materials and products that can be used in our everyday life. You can see the airplane up here. I'm sure many of us aren't doing too much airplane travel now with the pandemic, but it just kind of got my travel bug thinking when I saw that airplane. So hopefully you all are staying safe. I probably should have mentioned that at the beginning. I've been working from home since March here in Houston, and it's really, really nice to be able to present to you all today to share my story. Okay, so now we'll get into the exploration and production. So we talked about generally oil and gas. We talked about upstream, and that's where exploration and production resides within that stream of oil and gas business. So there's a life cycle even within subsea development, and it starts with exploration activities, because exploration is really going out and finding where exactly that hydrocarbon is located. And once you find potential hydrocarbon reservoir and you do some activities to confirm the viability of a potential reservoir, You would then do drilling activities, and that's really our focus for today is drilling. And so after you drill, if it is a profitable and a production well in which you can get hydrocarbons out from the well, you would then move into the next phase and complete that well. And I will touch on that at the end, where a subsea tree is installed on the wellhead, and then the necessary field architecture components are linked up to enable operations, which is the next step, and production. A field has it doesn't have an infinite timeline. A reservoir ideally is depleted. We do our part to make sure that we get the hydrocarbon safely and effectively out of the reservoir. And once that happens, the very last stage is to plug and abandon the field to make sure that the footprint that is left behind is of safety and meets all of the requirements of the local area in which we're operating. So with that, the first thing that you would need to do in order to confirm that you do have a viable development is to do exploration activities. And a seismic survey is the best way to do that. So there are specific companies that go out and do seismic analysis, and they use that information to be sure that the development is worth installing a well or drilling a well. So the seismic vessel will send sound signals down, through the water, and it will hit the initial mud line. And then depending on the type of sediment layers that you have, it will either permeate through and let you know that you have gas, oil, water. So the technology is out there today in some of, it's advanced a lot over the years to the fact where you can really understand what you have below the mud line before you do any activities. I had seen a presentation when I first started with the company, and back in the day before subsea wells, when there was just surface wells, really, a lot of times you would only strike oil by luck or by, just some hunch that there could be oil below the land. Now there's not a lot of guessing. Because of seismic data, we know we can tell in advance what is below there, and then ultimately decide based on the right-hand side, what we want to do with a particular reservoir. So it really takes the guessing out of it. So once you determine that you have a viable reservoir, the operator, so I work for a service company, but we support operators, globally. They will let us know after their engineers and geologists review the seismic data whether or not they want to develop a particular asset. So the first step in doing that is to install an exploration well. And this would be right here, the exploration wellhead itself. And so based on the seismic data, an exploration well is drilled. And then with that, you can gather data, the presence of the hydrocarbon. So you kind of confirm what you saw on paper, right? You want to install that exploration well, and you want to see if there are actually hydrocarbon there. So you would do an appraisal, and it's really appraising the value of the reservoir. So you would do a flowback in the case of an exploratory appraisal well, and you could then tell, once you bring the hydrocarbon back to a production facility, you would be able to determine the flow rate and the reservoir characteristics, and thus make a decision as an operator if you want to develop a field around this reservoir. So the reservoir is that area where there's dense hydrocarbon underneath the seafloor. So what we're seeing is a seafloor here. You could be talking that the reservoir is 5,000, 10,000, 15,000 feet below the surface. And so there's a pocket of hydrocarbons. There could be many pockets. But just as an example, if there was one centralized pocket of hydrocarbon underneath these wells, the operator would then make a decision based on, the characteristics of the well and the finances and everything, whether or not they want to actually develop a subsea field here. So if you get to the point where you want to develop a subsea field, you need to start considering the equipment that you're going to use for that development. And so I wanted to take just a brief step to explain the wellhead, because that's a crucial part of this development process and the drilling process. So the wellhead itself is what you saw in the previous slides, as far as the exploration well / appraisal well. This is a simplified wellhead that is showing different components of it. So the wellhead is essentially the pressure containing vessel that provides the means to hang off and seal casing used to get to that true vertical depth that you need to get to in the reservoir. So the wellhead portion that you see here is like above this brown is what you see above the mud line. Below the mud line here, you're going to have multiple different casings and strings that are going to go down to your reservoir. And like I said, those can go down to 20, 30,000 feet below that mud line. So the wellhead needs to be designed for that, the ability to hang off different casing hangers. And it also needs to be able to withstand the pressure that it's going to see from those different sections of the route to get to that reservoir. So it is a very sturdy, very well-designed product that is versatile in its ability to hang high, very high weight casings that go all the way down to the reservoir. So it also, the top here, the locking profile is going to allow for a subsea tree, and I'll show you more about that in a next slide. But it allows that if you decide, or the operator decides that they do want to produce, then you do need to put a subsea tree on the wellhead in order to do that. So it has that capability. It also, that same locking profile is able to be used for the blowout preventer. So when you're doing activities that expose the wellbore to the environment in any way, the blowout preventer has to be installed on top of the wellhead to prevent any potential exposure of hydrocarbons to the environment. So the wellhead allows you to land out the BOP on there. And just the last thing is, like I said, it's located on the ocean floor. It has to be, installed remotely at depths that we are operating at. There is no human intervention, 10,000 feet below sea level. So these products need to be installed from drill pipe that goes all the way down to the mud line and then installs this piece of equipment. So with that comes a lot of unique running tools to run specific products that we have. And as was mentioned in my introduction, I spent a lot of time when I first started in the industry working offshore in the Gulf of Mexico on a variety of different projects. And depending on the project and the operator, those rigs and or vessels all look different, but the goal is still the same, and a lot of the same tools are used. And so I'll get into some of that in a little bit. So on top, like I just mentioned here, the wellhead has a tree locking profile. So it has a tree locking profile so that the tree can land on here. And this is a cross section showing the wellhead. And on top of the wellhead, it's showing the subsea tree. And so the production tree will be, in this case, there's also different types of trees, but I'm going to focus on production for this discussion. So production means you're producing hydrocarbons out of the reservoir. And so the production tree lands on the wellhead and it controls and directs the flow of the hydrocarbon. So within the subsea tree, there's a series of valves that control the flow and ensure that it gets through the subsea tree and out through the jumper and eventually through pipelines and then up to the platform to be processed and then sent to land in a refinery to be further processed so that we can use it. But the tree sits on the seafloor on top of the wellhead and is used to control and direct the flow of hydrocarbon. So as an example of a production field, I'm going to show this production field. So you see a lot of different colors, predominantly yellow as one of the colors for the actual equipment. So this is like a, stepping back from the field and looking at it in its entirety. If you go in close to the different drill centers, so like I think you can see my mouse, but if not, the left part of the drawing is showing a drill center. It says DCA production. And if I'm just pointing to one of the subsea trees that is on a wellhead, and it ties back to a manifold, as does all of the other subsea trees that are in that drill center. So they will all tie back to a manifold, and then the hydrocarbon will be routed in the red lines. It will go back to the facility to be then, transported to eventually to a refinery. So the goal of the subsea equipment is to safely and effectively get the hydrocarbons out of the ground, and then there's infrastructure downstream of the subsea equipment that will allow for it to flow, and a lot of flow assurance will need to be taken into consideration. Every field is different. Even in the Gulf of Mexico alone, where I have most of my experience, you are going to have a lot of differences depending on where you are in the Gulf of Mexico. There are different depths, there is different seafloor topography, and as a operator, you need to account for that and be sure that you're contracting, the right service companies to provide equipment. You can do your own flow assurance and just make sure that you're going to have the correct equipment and also the proper flow assurance to allow for the hydrocarbons to actually flow freely through the pipes once you start to produce oil and gas. and or gas. So now we'll get into drilling the subsea well itself. So we talked a lot about, the building blocks of a subsea wellhead and then the subsea tree, but how do we actually drill a subsea well? So a lot needs to be taken into consideration when you determine that you do have viable hydrocarbon through that exploration well that you would have done. So you would have done your exploration well, you would have done an appraisal to be sure that you had the right characteristics and you wanted to produce out of this field. So as a part of getting your production field going, you need to select the type of rig that you want to use. So there are many different kinds, but all of them, like I mentioned, they're out there to do the same thing. There are different considerations that you need to take into consideration when you're deciding which one that you want to use. And a lot of it is based on water depth, and some of it is based on existing infrastructure in the country in which you are developing your oil and gas. So, you have a jackup, you have a semi-sub, and you have a drill ship. Those are the three that I'm showing here. There are other types, but these are just a couple of options that you can choose from as an operator to decide how you want to go about developing your field. So the jackup is going to be for shallower water. You don't want to go, above, I think the depth, the max depth is probably 500 feet. The jackup itself is towed to a location using boats. The legs are lowered, they penetrate into the seabed. So it's a fixed platform that can reach, the bottom of the ocean. So it's sitting on the seafloor. The derrick, which is a common characteristic of any type of rig that you choose. This particular one is cantilevered outward from the main deck, and the water depth is limited by the height of the legs, obviously. So that would all have to be pre-designed in advance. And it has to be like a stable environment because it is fixed. And if it was a, dangerous environment as far as harsh weather conditions, you just need to design for all of that. A semi-sub. So this is moored / anchored. You see a lot of these in the Gulf of Mexico. They are like small floating islands. A lot of the time that is what they get called. They can be quite large and they can go up to a water depth of 10,000 feet, which oftentimes that's what our equipment is designed for, to go to 10,000 feet of water. So this is on the upper end of, what you would want in a deep water development. So the next one is a drill ship. So you also see these quite often. They can go also up to 10,000 feet. They have a unique characteristic where they are dynamically positioned. So at all times to station keep over where the reservoir is and where you want to drill. The boat, the ship has the ability to stay in place using different frequencies that are transmitted to transponders subsea that are placed in advance of the drill ship going out, and it has that ability to stay in place without manual intervention. So dynamic positioning is key to be able to keep that drill ship in place. As you can imagine, it's pretty large, and you want to always know where it's going to be and keep it in place so that you're not pulling any unnecessary tension or putting your drill string in compression or any of those things that could cause negative results for your development. So to talk about the drill string. So like I said, each of the different rigs that you choose, they're all going to have the ability to install and drill a well. And each of those are going to have a drill string that's going to extend from the platform or the semi-sub or the drill ship, and allow it to hang a drill string and to drill for the hydrocarbon. So very simplistic photo on the right, but it's showing the drill string going down through the different layers of rock and sediment in order to get to that blue, which is your hydrocarbon that you want to get to. So the drill string consists of a combination of things: the drill pipe, the heavyweight drill pipe, drill collars, and a bottom hole assembly. So the drill pipe itself make up the majority of the drill string back to the surface. So there's going to be different joints that are going to be connected together. They are welded together and are usually around 30-40 feet each joint. And so that has to, if you can imagine, being in 10,000 feet of water or even 5,000 feet of water, you need to make up the drill string that's going to go from your platform all the way to the mud line and beyond. So the drill string can be very long, and all of the rigs need to account for the ability to have storage for that amount of drill pipe, and also the ability to run that drill pipe and weld it as you go, because you're not going to be able to have drill pipe 10,000 feet welded on your platform, no matter how large it is. You're going to have it in sections and then weld it together as you go through the process to get to your true vertical depth. So the bottom hole assembly is circled here in red, and that consists of a combination of things. You have your drill bit, you have your mud motor, and you have potentially, if your well requires deviation, you have directional deviation tools. You also are going to need to have management tools as far as understanding where your drill bit is. So you have measurement while drilling tools, and you have logging while drilling tools. That is essential in the process, because you can't be there to touch, feel, see yourself. So there's technology that allows you to be able to monitor your bit and mud motor and your deviation tools as they're being drilled into the formation. So the bit, which is a part of that bottom hole assembly, it is responsible for cutting and crushing rocks that come into its path to get you down to where you need to go. There are different types that have pros and cons to each, and it's up to the operator to decide what they need for their development. And I've just listed out a couple. And then, as you can see, there are factors in deciding which ones that you want to use. So like I said, really comes down to what the operator needs. They are the ones that understand that formation and understand what they need to do to get to the true vertical depth in the reservoir to start producing oil. So we as the service company basically just get the end result of them doing the analysis. And so they would be the ones that are responsible for deciding what they need for the drill string. The motor uses the hydraulic horsepower. So the motor is what's going to allow you to penetrate through the rock and keep moving through it. It had, the motor, which is transmitted as concentric power to the bit. So it's constantly rotating. And increase, this can also be used for directional drilling. So there are times when the reservoir is not directly underneath the rig, and you may have to do a sidetrack and kick off a little bit from directly vertical. And so these tools are extremely advanced. There's a lot of technology out there that enables you to be able to do deviated drilling as well. So this is just an example of some directional deviation tools. So a steerable motor assembly or positive displacement. This one would have, like you can see to the right, where there's that blue adjustable bent housing. So the bend is located in the motor or the short sub behind the motor, and it is there to change course to enable you to kind of kick off a bit from that directly vertical drill that would be just too easy to have it directly under. So there's going to be times where you're going to have to kick off. And then this is just the measurement while drilling tools. So this is going to be very important to know where you are. So you always want to know your vertical inclination. It's key to know at all times from the rig where you're going. And so measurement while drilling tools are needed for that. And the valves modulate the flow of drilling fluid and mud that propagate up the drill string. And that's going to tell you where you are. The logging while drilling is another, technology that is used, and it uses gamma ray density basically to emit signals. You can see the green here. It's a pre-installed seabed receiving antenna that is going to be able to communicate with the logging while drilling tool that's below the mud line to know at all times where that is. And then that seabed receiving antenna is connected to your rig so that it can communicate. So they're manned platforms. And so there's going to be people on there that are going to be reading that data to ensure that you're where you want to be. And then a very important component of drilling is mud. So the drilling fluid / mud is a key in ensuring that you're going to be able to cool the rock that is being pushed out of the way to allow for you to drill. So the drilling fluid does a lot, and one of it is to prevent the collapse of the formation or to maintain the borehole stability. So an analysis will be done as soon as you know the characteristics of your formation and where the depth is that you want to go. Because as we showed, like that cross section at the beginning of the presentation, not every part of the sediments are going to be alike. And as you go down deeper, the pressures are going to change, temperatures are going to change. So you need to do mud calculations in advance to know the weight of the mud that you're going to be using, depending on the section of the development that you're in. So like I mentioned, it also keeps your drilling bit cool. You don't want that to get too hot, and the mud allows you to be able to cool that down. And it lubricates the drill string. It serves also as a removal conduit to the drill cuttings. So the mud actually helped to push the drill cuttings up the string, and they're continuously, the mud is circulated down, and then with it comes up the drill cuttings. So this is showing how the mud would be calculated. So what is the mud that you're going to need to use? Mud engineers are a huge part of this process, and they work with the operator to determine the type of mud that needs to be pumped down the string during drilling operations. So different sections are going to require different mud, and it's all based on where you are below the mud line. So this green rectangle here, the top of it is showing that would be your mud line. And below it are going to be the different sections that you need to drill in order to get to your depth, your target depth, or your true vertical depth. Within those steps, the different blocks of green, you're going to be experiencing different pressures. So the pore pressure is going to change as you go down, and also the fracture pressure is also going to change. And that's all based on the hydrostatic head that you're going to encounter as you're pushing rock away. And then you have the column of fluid that's above your drill string. You need to take that into consideration as you develop your mud program. There's also safety factors that need to come into play. So this is all in deciding the drilling and casing program. You want to start at the bottom and work your way up. To ensure that you're never going to fracture, you're never going to go above the red line, and you're never going to go below the blue line. You have to be within the sweet spot in between those lines to create your mud program and your casing program to ensure that you're able to get to your depth safely and produce hydrocarbons out of this without any collapse. So there's a lot of pressures and weights and that need to be taken into consideration when doing this design work for your reservoir and for your casing. So in order to drill a hole, the volume of rock must be removed. So the column is being hollowed out, and how do we do that? And what happens to the rock that is removed? So you drill the hole, the blue line is showing, or the blue drill string is showing that you go down to the depth. At the bottom is your bit, and you have to get that rock out of there. So it must be removed. How does that happen? So the rocks are being cut or crushed into many tiny drill cuttings. The friction in the drill string from the rock formation in the drill cuttings is present. The drill bit heats up due to friction from the drill cuttings, and then ultimately moves its way up the string and returns back to your rig or your platform, and then it is processed and potentially reused to continue with your drilling operation. So now moving on, we talked a lot about mud, and I touched on casing, but in order to get to your true vertical depth and the removal of the rock in order to get there, you need to have casing in place. So basically your foundation needs to be present in order to get to your depth. So you start off with the conductor casing, then you move on to surface casing, intermediate, production, and then your final tubing, which would go down to your true vertical depth. Each development is going to have its own wellbore schematic, is what it's called. And the wellbore schematic is going to outline what dimensions that the casing needs to be. And this is all based on the operator working to ensure that they isolate the formation and control the formation pressure. So it's an act of making sure that you stay in a position where you don't have any fractures and you are above the pore pressure, so that you are able to produce and the hydrocarbons are able to flow where you want them to. So the number of casing string runs depends on the well depth. Like I mentioned before, the true vertical depth can be 10,000 feet below the mud line, or it can be 30,000 feet. It really depends on where that hydrocarbon has formed and the reservoir in which you're developing from. So the formation pressure versus fracture gradient, this is also important when you're designing your casing. So formation pore pressure, the pressure of fluids within the pores of a reservoir. So The drilling mud pressure must be held above the formation pressure in order to keep the wellbore stable. So you don't want your well to collapse. So you need to be above that. And the fracture pressure is the maximum pressure at which the formation can maintain stability, and the drilling mud must be held under the fracture pressure in order to avoid damaging or destroying the well. So the right-hand side here is just showing different sections of the casing and typical casing sizes, and it can vary, but typically the conductor, you're either going to have 30-inch or 36-inch conductor housing, and that's going to go down to 500 feet below the mud line. And then what's called your surface casing is 20 inches in diameter and can go down to approximately, this is just typical, but approximately 2,000 feet below the mud line. And then the size of the intermediate, which is the next level down, is going to be 13 3/8. And then production, you see that we're getting smaller. You know, each time you're getting to a smaller diameter, and eventually you're going to get to your production tubing, which is going to be the 9 5/8 inches or 10 3/4. And that is where you would eventually perforate into your wellbore to get hydrocarbons to start coming into that production tubing and up your pipe. So again, here's just another example of a typical casing program that would be developed by an operator and given to a service company, such as the one that I work for within Technip FMC. They would let us know this, excuse me, they would tell us the different sizes of casing hanger that they're going to run. And then we in turn provide them with running tools to run the different sections of the casing hanger. So we have the ability to install the wellhead, and then as a part of that, we install the different conductor housings for them. But it's really all dependent on the casing design, which tools that we bring to the rig when we are called out to do an operation. And typically you know, as a service company, we get involved very early on because there's often times where we would have suggestions, or we may have a different tool that could be run to save time. So it's just something that's shared early on in the tendering stage, is the wellbore schematic, so that we know the different types of casing that we need to run during our drilling operation. So now we're going to get into drilling the well, and there's going to be a series of slides that are kind of, they're cartoon, but it's a good way to, at least I hope that you find it a good way to visualize how a well is drilled. So the right-hand side is that wellhead that I talked about earlier, and it's showing the high pressure housing. And so to the left hand is that like kind of cartoon view that we'll start talking about. So the red section is going to be your high pressure housing, and then the blue down here is going to be your low pressure housing. So in the next couple of slides, I'm going to show what's installed first and when each item is going to be installed as a part of drilling the well. So this is showing that the drill bit is going down through the rock to get to the blue thin layer of the reservoir. So the initial step, that is called spudding a well. So if you ever hear somebody say that they're going to spud a well, that means it's the very first step in the process where you're going to go and you're going to begin to install your subsea wellhead. With the first step of that, oh, I'm sorry about that. You are going to install your low pressure housing, and that's the first step that would be done, and it is going to have a specific casing on it to begin the process. So that's going to be your low pressure housing and your initial run of casing. So that casing, just like every other run, will need to be cemented in place to provide a stable foundation to build your well on. So you need to be able to cement it to ensure that it doesn't move at all during the process. So you've cemented it on all sides. That is not going to be a problem for the drill string. The drill string is going to come down and it's going to get that, cement out. It's going to drill right through that and it's going to get to the next level. And then we're going to install another section of casing, and that, would get into, we're working our way to get to the reservoir. So each time we go in and we install another section of casing, we are getting closer to that true vertical depth of our reservoir. So that particular one was hung from the high pressure housing, which can take the weight of all of the different casings to get to your true vertical depth. So we're continuing the process. Each of these steps, and I'll just go back because I forgot to mention that each of these steps, when you have the well bore open, you are going to require right here the blowout preventer to come on site as soon as you begin to run drill pipe from your rig in order to get that comfort of knowing that you have a blowout preventer available in the event of any kick to your well. So if there was ever a time that you were getting additional pressure that you plan for, but you hope does not happen, your blowout preventer is going to ensure that you never have any impact to the environment. So you're continuing to drill out, and eventually you're going to, land another casing hanger to get you further down to your reservoir. And then the very last would be your tubing that would be hung, that will get you to your true vertical depth. And once you're there, you can then complete the well. So as a part of completing the well, we need to install a subsea tree onto the wellhead. So the subsea tree has a tubing hanger that hangs from it, and we have a couple of variations of subsea trees in the industry and that we provide at the company that I work for. And this particular one is going to be the vertical style, in which it has a tubing head spool to the right-hand side, but the principle is still the same, that a tubing hanger is hung from the tree and it goes all the way down to your true vertical depth, where you're eventually going to perforate to get the hydrocarbons into the production tubing, up through the tree, and then eventually through your production outlet, which is up here, and into your flow line up to your topsides facility, and then downstream of that, it would go and be refined. So the completion of a well is gonna, and we looked at this slide before, but just as a reminder, the tree lands on the wellhead, the hydrocarbon is gonna come up through the production tubing all the way up to the tree and be routed out through the jumper and into the production flow line. Well, first a manifold production flow line, and then to your topsides facility to be eventually refined further. The perforation that's going to happen at the bottom of that string is going to be done by an electric wire, essentially, that is deployed from topsides that has a perforating gun at the bottom of it, and it's going to perforate the section that you want it to and allow for hydrocarbons to flow into the string. And that is all controlled by topside. So the completion work string, the electric line, simplistic cartoon, but I think it's a good illustration that the electric line will come down through the very last section of the tubing, and then you will perforate the blue, or perforate out to the blue, to allow for flow of hydrocarbon into your string, and then eventually up through the string, as I mentioned before. And yeah, so that's the very last thing that would be done, is your installation of your tubing string to allow for hydrocarbons to flow freely up that 10, 15, 20,000 feet up to the tree, and then routed out through the manifold and to your topsides facility so that it can be further processed. So that would be the flow of hydrocarbons. So once it's perforated in this section, the flow of hydrocarbons would go up, and this arrow is just illustrating that it would go upwards in the direction that you would want it to. So that is all of my presentation, but that is not all the time that we have. So I would be happy to answer any questions that you have. And I hope you enjoyed the presentation. I think you might be on mute.
Can you hear me now? Yes.
Yes,
I was saying
perfectly.
thank you so much for doing the
You're
presentation.
welcome.
It was really insightful. We do have
Good.
some questions. One is from Daisy Senda. She's saying, hey, everyone, working in such major gas production area, full area Gulf of Mexico requires a lot of cutting edge technologies as well as expertise of the operators. I would like to know what was the most complex or challenging situation you faced while providing subsea services, taking into account the area being operated, Gulf of Mexico, known as a harsh weather area.
Daisy, thank you for your question. So major gas production areas such as the Gulf of Mexico definitely requires cutting edge technologies. You are so right. There is a lot of developments that have happened over the course of my career, which is short compared to some, but there's definitely been a lot of technological advances that I've been a part of. So I'm trying to think, what would be the most complex and challenging situation? So I can give you one that I have been a part of personally, and then I can kind of try to provide some others that I have heard of. So when I first started with the company in 2009, it happened to not very long after I started with the company, Macondo happened, which changed our industry forever. And, for those of you who don't know about Macondo, I'm sure that you do, but it was a major oil spill in the Gulf of Mexico. And so our company wasn't directly involved in the actual field, or our equipment wasn't a part of the original development. However, we worked with the operator at the time, and we developed in a very short amount of time, because that's the thing about offshore oil developments. And you have to be things happen very quickly, and you have to be able to respond and be on your toes at all times. And so our company responded by developing different parts of technology that we had in our toolbox. We were able to design a capping stack, which was one of the remediation methods that was being deployed to stop the hydrocarbon from flowing into the ocean. So as a part of that, we were able to, work with the operator closely, put pieces of equipment together that may not have been exactly designed as a safety tool, and use it to better, serve in an emergency situation. So that was a very complex, challenging situation that I was a part of directly, as I worked offshore during that time and was able to help deploy that system for our company in aid of protecting, the environment and helping with that. You talk about harsh weather. So that is another thing that Gulf of Mexico, in the big global picture, may not be considered some of the harshest. I come from St. John's, Newfoundland, Canada, East Coast, which is more of an Arctic subsea environment, which has its own challenges, where there's icebergs and different things like that. But in the Gulf of Mexico, you probably have been hearing a lot of hurricanes that have been happening in the region. There have been like an unprecedented amount this season, in which that really slows down activities for us. Our company does a lot of different things in the water, where we own a lot of vessels and we do a lot of pipeline installations. So to that effect, we just, again, have to be ready for operations to be postponed, or we have to have the ability when there's a hurricane to respond quickly and be able to get to safer waters and help the operator in any way that we can there. In addition, like as far as the Gulf of Mexico, another key thing about this region, because I think that was specifically what you wanted to hone in on, was the Gulf. It's deep water and deeper reservoirs, and we're going further than we ever have subsea. And so with that comes the need to think about ways that we can do things more efficiently. And with our company, one of our foundational beliefs is sustainability. And as a part of that, we have been developing and putting a lot of effort and engineering resources and time into developing technologies that have a lower carbon footprint, and also just in general that they're smaller. And so technology that, instead of having, large pieces of equipment that need to be installed, we have worked on technology that enables our products to be smaller, so that they can be installed faster and more safely, because the less parts, the less installations that you have to do. And so we are looking at ways, and the industry as a whole are constantly looking at ways to improve operations and make them safer and more efficient, so that we can harvest hydrocarbons in the most effective way. And just lastly, we have, something that I never touched on much today, but I'm sure many of you can envision that subsea developments in the ultra deep waters that we're in require remote operated vehicles to actually sit subsea and monitor all of the activities that we're doing on the seafloor. So we have also invested a lot of time and engineering resources into developing a remote operated vehicle that can stay underwater longer, and it can do things that really aid in assisting the operator in activities subsea. Because, like I mentioned in a couple of examples, things don't always go as planned. Things rarely go as planned, and so you have to have all of the design work, done up front, and you also want to have the ability to do things as fast as possible to cut down on time and exposure that you're out there. So I hope that answers your question. So thank you for that.
Thank you, Julia. I think it does because it's basically reduction of costs, I would say, trying to make it more feasible, but also not having big machines deep water, right?
Exactly.
So we have another question. It says, hi all,
Sure.
as the number of casings depends on formation pressure, fracture pressure, and depth, how many casings at least must be installed in a standard well, which has low pressures and a very small depth?
Good question. So, Alberto, I thank you for your question. And it's definitely the casing program is going to change depending on the well that you're going to. So I would think that, and I will, if I had time, I would double check for you. But I believe that as a minimum, you would need 3 sections of casing in order to, at a minimum, if you have a shallow depth below the mud line, you're going to need that initial section, the initial conductor casing, and then you're going to need your surface casing, and then you would need just intermediate casing. I have never seen anything less than 3 casing sections, but that doesn't mean that it doesn't exist. But I just think in order to get down to that depth and not have the volume of the hydrocarbons coming up too large to be able to control, I think you need to have smaller sections. Even if it is gas and oil mixed together, I think you want to really get down to a lower diameter. So I think 3 would be the answer. But that's a good question. I appreciate it, and I think it's 3.
Thank you, Julia. Another
No.
one from an anonymous attendee. It's asking, what are the major precautions, health and safety conditions we must consider while drilling a well?
So the major health and safety that we need to take into account, number one, with any company and anybody, safety of people is always going to be the number one thing that we focus on. So at all times, we need to keep our people safe. And so that's for sure obvious. Another is for sure and also obvious is that we need to keep the environment very safe. And that always needs to be taken into consideration when we're doing any sort of drilling activity. So with both of those things into consideration, I would say that some of the major risks that are out there that we need to design out and or ensure that if they happen, that we have the means in which to prevent harm to people and harm to the environment. So I touched on it briefly, but as part of drilling, when you get to depths in which hydrocarbons start to or could potentially come into your drill string, you need to have the ability to close off those hydrocarbons to the environment, because there are times when things can go differently than what you had planned, and you may have a kick in the well, in which a kick means that you have pressure coming in that you didn't anticipate, and so you need to be able to handle that. And we have ways in which we do that in the industry. You have the ability to pump down heavier fluids to ensure that nothing comes up. You also have the ability to close off valves in the blowout preventer to ensure that no hydrocarbon gets past that BOP that lands directly on the wellhead. So those are just a couple that of issues that can happen subsea. On the topsides part of it, like on your platform, you have to have a very robust safety program to ensure that people are not getting into harm's way when you're lifting extremely heavy very large pieces of equipment. When I worked offshore, I know I work on teams now where people are working offshore. We have the industry, and I'm not just speaking about my company that I work for, but in general, there are so many safety factors put on everything. And only, essential personnel are allowed to be in a position of, with the equipment that's being run. Only essential personnel. Before every operation, you have to do a job safety analysis. So everybody who's going to be involved gets together and goes through every single operation to make sure everybody understands and that all the risks are identified for that particular activity. So as an example, if you're picking up a piece of pipe, that whole crew that's involved in the operation need to be aware of that activity and what could potentially happen to that pipe. So it's always planning ahead to be sure that you're ready. And it's also having a stop the job philosophy in the oil industry, where if there was ever a time where somebody didn't understand something, or if you weren't comfortable with the operation, every single person is empowered to say, excuse me, I'm not quite sure what's happening here. I'm not aware of this product and I'd like to understand a little bit more. So safety is always number one. The risks are countless, right? Like I could go on about different things that can happen, but you engineer them out, or that's the first thing you want to do, is engineer them out. The second thing you want to do is just make sure that anything that can happen out there with a lot of heavy machinery and equipment, that you're prepared for it. So that's really all that I have on that one.
Thank you, Julia. We
You're
have
welcome.
two more questions, I believe. I think it's three. So
Perfect.
this one is from Shayla. She's saying, "Hi all. I would like to know whether you did choose to take that career path or it happened accidentally. Could you just quickly explain how was your hiring process? I'm both a mechanical and petroleum engineer, but unfortunately, I'm still out of work. And nice presentation. Thank you."
You're so welcome, Sheila. Well, that's a great question. So when I started university, so a lot of people know what they want to do before they go to university. And I recommend that. I think it would be great. I would love to have known. But in the same breath, I can't say that I would have done things differently. So here's my story. So I graduated from high school and I wanted to be a pharmacist. And I just thought that was what I wanted to be. I figured, I'd go to pharmacy school, and I must have seen it on a television program or so. I don't know where that came from. There's nothing wrong with being a pharmacist. Don't get me wrong. It's just, that's what I thought I wanted to be. So when I went to university, I did a lot of chemistry. I did some biology, and I did a minor in physics, and I loved it. And I didn't do so hot in the other subjects. And then when it came down to it, when you do kind of a first year in my university of general studies, and then you can pick your discipline, right? What you want to go into as your career. And I excelled in physics and math. And I looked at the industry. So in offshore Newfoundland and Labrador, where I grew up, the oil industry was very popular at the time, and it looked like a great, prosperous, industry to get involved in. And I was the type that I really wanted to know that I was going into something that a job would be waiting for at the end of the day. Not knowing much about the oil industry, I did know that there was a lot of work. So the interest in physics and math, the industry where I lived in an island, off the coast of Newfoundland, oil and gas was a very big part of growing up for me. And so I decided to go into engineering. I decided on mechanical because I felt like it was the most versatile of the degrees. I evaluated each one: civil, chemical, and naval, and I decided on mechanical. I've never really looked back. I do believe, and when my bio was read, I've done a lot of different roles within the company that aren't necessarily engineering roles. It was a foot in the door for me with the company that I'm with now. I have worked in roles that are sales. I've worked in roles that are offshore. I've worked in roles that are developing field architecture. And now I'm a project manager of a project in the Gulf of Mexico. So I would say happening by accident, not really. Happening by using the skills that I have and my strengths, and really, doing that and having a goal at the end to work in the oil and gas industry. Like, I'll never forget the day that I went offshore for the first time, and the things that I was reading in a book became real. And I never have taken that for granted since the day that I started working. So I think that the opportunities that I have been given, I've kept a positive mind. I've kept an open mind. Little did I know, when I started, that this industry is very volatile. I mean, there's ups and downs. There are challenges. And so I would say to you, Sheila, for sure, don't give up if you're still looking for a job. And I think that might be what you said. I had to, I'm not promoting that you move, but I'm just saying I had to move countries because at the time when I started my degree, the industry was booming in where I was from. When I stopped my degree, I wasn't able to get a job in my hometown. And so I moved. And so, I mean, you have to do what's best for you. And some of that may involve doing things that you might not be comfortable with, and it may be a little outside your comfort zone. But I would say that it will shape you, and now is the time to take advantage of what you have going on in your world, and then look for opportunities that it may not be exactly what you want, but it's a foot in the door to a good company, for example. So I encourage you to just keep with it. And if you don't find something right away, don't work try to pick up a job that's not in your field. You never know who you'll meet. You'll never know who you'll network with. Get involved. This organization, the Mozambique Women of Energy, I mean, what a phenomenal opportunity to meet other people that you may have something in common with. Get to know them. I know we can't do it that much face to face right now, but try to set up calls with people if you want to have a one-on-one. I remember you have to be bold when you start. And I would try, and sometimes people be like, no, I don't want to meet with you. But I would try to meet with people and get their opinion on different roles within the company that I work for. And people don't forget that. If you take a genuine interest in them and what your company can do and might be doing, or even if it's not your company, if your friend is involved in something and they have a friend, just have your ears open, have your mind open. It's not always easy, and it's not, every day for me is not roses and buttercups and perfect by any means. There are challenges in the industry. We're in a global pandemic, so give yourself some time. Don't put too much pressure on yourself, and try to use the resources that are available to get where you want to go.
Thank you so much, Julia. Thank you for the advice. I think it can apply in all areas, not only engineering, but everything in life. So thank you so much. So another question, we have two more. It's from Pedro Chuva. He's saying, hey, Julia, congrats. Please just receive my few recommendations. Actually, when drilling a subsea well starts with jetting conductor pipe, after installation of BOP and marine riser in drill ship, that is. Also, instead of TBD, we can use mostly MD because TBD can remain the same always, but MD can increase always. My question is, Why do you need to use a DC and HWDP in drill string? And why is DC and HWDP not included in BHA itself according to your slide? How can we know exactly fracture pressure for a specific section? So maybe explain a little bit of this
Yeah, sure.
deviations.
Yeah, so I think that the drill string itself is going to be dependent on the specific development that you're in. My slide was more of an example of what a drill string could look like. So I think that might answer the first part. The bottom hole assembly itself, it's just, by definition, it's just the bit, the motor, that bottom part of your assembly. So, I mean, potentially you could classify the end of the pipe as a part of the BHA itself because it needs to, eventually go through that bottom hole assembly. But the bottom hole assembly itself it's by definition the items that I had included on the slide. And then how do you know the exact fracture pressure for a specific section? So that comes down to some data that you would have to get in advance of drilling through seismic. You would also have to do that exploration well, like close by, where you would get a feel for the different pressures and temperatures and characteristics of the well in advance. I would definitely say that I'm not a specialist by any means on how to drill a well. So your comments are fully noted. And I would say that you're more than likely an expert by the sounds of it. So really cool. I'm learning a lot just reading through some of your comments. But yeah, I think the pressure, the maximum pressure that's there is all based on the characteristics of the reservoir itself. And the operator would be able to gather this through understanding through the seismic data and the initial calculations and stuff that they would run related to the different sediments that they're getting through that seismic, and then also through a exploration well that they would know what they would need. So again, geologists play a big part in it. The Earth's crust and the sediment, all of that plays a big part in knowing how it's going to be. And then of course the column weight. So if depending on how deep the well is itself. So if you're 10,000 feet below sea level, and then you have to go down another 30,000 feet, all of that weight calculations need to play into exactly what it would take to fracture the well. So you want to stay under that because you don't want to fracture sections that you're not intending to, but you want to stay above the pore pressure because you also don't want to collapse the well. So again, great comments. Definitely not the expert here, but sounds like you have a really good handle on everything. So I hope that you enjoyed it, Pedro, and thanks for the question.
Thank you. Another one from Alberto. Are there training opportunities for graduates in the oil industry, in this case in drilling field, at the moment taking into account the current pandemic disease?
So I would say that because of the pandemic, I have been finding that there are more trainings and different webinars available online if you want to do something informal, right? Like, for example, our company is doing these 15-minute subsea in-depth with the expert discussions. And we are doing those. We just started them, and anybody can dial in. You can go to our website, technipfmc.com, and you can sign up for a 15-minute expert discussion on a given topic. I encourage you, and because I've done it, I have attended during lunch break when you're in the office or you're working or you're in your daily life. I I find that it's harder to find time for training. I would say now companies know and resources are becoming available to be able to do more from your computer. So that means that you have access to things that, you know, may not be next door to you, but they could be across the globe, and you can sign on through webinar or through Teams or Zoom or whatever the case is. So have a look. I honestly, I find Facebook a good resource. You can search like events and you can find oil and gas events through women. I'm sure through your women's and energy group here, there's probably some sub groups within this one. And then, like I said, I just know of one that we're doing at our company where you can get to know a little bit more about what we do. So I encourage you to check that out as well. So training, so that's like the informal get to know the industry through SPE is another one. Society of Petroleum Engineers. Actually, I did a training. You just dial in, it's free. And it's somebody that talks through a particular something specific that they are working on, a case study. So SPE is another one. And I know that there are many others that are just not coming to my mind right now. And then LinkedIn is another good way that you can find seminars and webinars and things like that. So that's like the informal, maybe not related to employment, but will help you get educated. Related to employment, within different companies, I think you will find that, you know, there is still hiring happening, and especially, you know, in oil and gas, it is a very fluid time right now. But I think if you're looking for opportunities, you will find companies that have a brief like training program at the start of your career where it's kind of on the job training. So that was what it was called when I started with my company. But as an example, we have a 3-year rotational program at Technip FMC where you start off for 4 months in one product line, and then you finish in something completely different. And by the end of it, you know, you've seen 12 different parts of our company. And so like that's just an example of some training that you can do if you find an employer that does that. So I urge you, when you do start looking for your jobs, that you do look for companies that value training, because, you know, day to day, we can get caught up in our day-to-day tasks. But our company and a lot of companies in oil and gas really value their employees being trained in multiple areas. So definitely take a look at some of those places that I mentioned. And also, when you're looking for your career, make sure that you pick a values training, because I think that we want to, a lot of us, and if you're dialing into this call, you want to learn, right? Like you like learning, you are eager to learn. And if you're working for a company that doesn't value that, I think that you will find yourself not fulfilling your need to learn. So that's just some ideas that I had on that one. So.
Thank you, Julia. Last question is from Thelma, and she's asking, what were your biggest challenges as a woman in the oil and gas industry?
So, Thelma, definitely a lot of challenges as a woman in the oil and gas industry. I would never be able to say that there aren't any challenges associated with being a woman in this industry. It's predominantly male industry. So that in itself, I find a little bit, especially when I started, I mean, it was just different, right? Like it was people that don't, you know, they don't look just like you. And it was I was probably the only female offshore for, you know, weeks at a time. And that was strange. And you can find yourself feeling isolated at times, and I definitely did. But then I think eventually something just hit where, I was doing some of it to myself and saying, oh, I'm never going to be in that role because no woman has ever been in that role before. But that's all negative self-talk, and that is not going to move women forward. And so I think that over the course of my career, I started, and I've always felt like equipping yourself with the tools necessary to get to a position is number one. I mean, I'm a mechanical engineer. I work hard. I pride myself on that. But there are challenges because you're trailblazing still. It's 2020. And there's a lot of roles that I'm doing in my company. I'm the first woman that's ever done it. And that in itself is not challenging, but it's a bit scary. And I feel like sometimes because you're the first woman, maybe you're being viewed differently, and they're like, oh well, I wonder, can she handle it? Again, these are things that I'm thinking in my own mind, but I also know that biases do exist. We can't pretend that they don't, and we need to recognize that we're different. We need to use our strengths. We need to demand a seat at the table. And I feel that it's been challenging, but it's also been extremely rewarding when I see changes happening in the industry. And it really does start with you. That might sound a bit cliche, but it's true. Like, you have to be the change that you want to see in your company, and you have to apply for the job that you want. If you don't apply, and if you don't tell people what you want, then you're not going to get it. So challenges would be going offshore, nobody looking like me, wondering if I belonged out there, applying for jobs that have never been occupied by a woman, getting them, wondering if I was going to do good. Just not having the same amount of people around you that are women is sometimes intimidating, and there's no doubt about that. So we have to stay focused on what we want, and we can't let obstacles, because there are going to be people that are biased against lots of different things, not just the sex that you are. And so you have to be yourself, and you have to be strong, and you have to do what you want to do, and don't let things knock you down. And if they do knock you down, you have to be, keep focused on your goals. I would say that there have been a lot of good role models. Get a mentor. Find somebody. It doesn't have to be somebody in your company. Doesn't have to be somebody that is higher up in the company than you, or higher up in their development than you are. Find somebody that can help you to achieve your goals, that has been through things that maybe you haven't been through, and they can help you through experience. Reach out for help, and don't worry too much about what specific individuals think. If you have people that don't believe in you, think about the big picture. You're skilled, you're able, you're determined. And that is really what I had to tell myself. And I'm seeing a lot of strong females emerge within all of the oil and gas companies. There are women that are excelling, but we still have a ways to go. And by getting more women in the oil and gas industry, we have more chances to move up in the company and be leaders. And I truly believe that there needs to be just as many men and women in leadership positions at companies, but you need to get into the company, and you need to start working on that and developing yourself in order to get there. So my biggest challenges have been making sure to stay as dedicated and up to date on all of my skills and training, so that I'm equal there with a male. But then also, just keeping your head up and focusing that not everybody is going to believe in you, and you have to be okay with that.
Thank you so much, Julia. That was all the questions. I just want to say in the name
Awesome.
of MWE, thank you so much for doing this presentation. It was really insightful, not only in drilling operation, but also in choosing your career path. And as a woman, that you need to be able to do it and just not think of what people are thinking. So thank you so much. I want to thank all the participants. As MWE, we're trying to do these episodes monthly where we have professionals like you explaining to students and other professionals what do you do day by day, because many people don't have this knowledge. They can read through, they can see the TV or the internet, but they don't know actually what someone is actually doing day by day. So I believe what MW is trying to do, even though with the pandemic now online, this was supposed to be like face to face, but we adapted and it's still amazing. We're getting results. So thank you again so much. And we hope to see you soon.
You're so welcome. I'm really impressed with your organization. I was so happy to be a part of this today. Thank you very much.
So this is going to be our goodbye. So if you guys want to check this episode, it's going to be within this week or the next, and keep update, and we will keep you updated with all the upcoming episodes. Thank you so much. Have a nice afternoon and goodbye, everyone. Bye, Julia.
Thank you. Bye.
Bye.